Hi, and welcome to this video about average velocity and average speed. So if you had just previously watched the video about slope, I kind of left you hanging and we were going to wonder about what about, I have the same position time graph, what about from 0 seconds all the way to 25 seconds? But before we get to that, I'm just going to mention that just for you to notice that this is the first time I'm talking about average. So up until now, we've always been talking about constant velocity, and now we've kind of shifted a little bit to talk about average velocity. So before we do that, let's look at this position time graph. We can say for this segment, I'll maybe label it A, it is going at a constant velocity, and you can tell that because it's a straight line. And then for B, it is going at a second constant velocity, a different one. So overall, this object is not going at a constant velocity because it changes halfway through. So our question would be, what about from this entire period of time? If it starts at 0 seconds and ends at 25 seconds, how could we figure out the average velocity? Because clearly it's not going constant the whole time. So often it's very helpful when we're doing questions to not just have a graphical representation but also have a motion map. So before I go into talking about how to do average velocity, let's do this motion map here. And I guess our question to start off would be is how would we scale this, because we are starting at 30 meters and we're going back to 25. If I go up by fives, I think it'll kind of work. Here we see if I go up by fives, I have to add a little extra tick at the end to make 30 meters, but that's not too bad. The next thing I need to do is think about where I start. So I'm going to be starting at the 30 meters part. So I'm going to put a dot there. I'll write the word start. The next thing is if I put a dot every second, I would end up putting 25 dots, and I think that's a bit too many. So what I'm going to say in this question, I'm going to put a dot every 5 seconds instead, and then it's similar to the graph because the graph, each tick here is 5 seconds. So that's a choice that we're going to make. So my first one is at 30. At 5 seconds later, at t equals 5, I'll be at 20, so I'll put a dot there. So I don't have to do this. I'll just put t equals 0 here and a t equals 5 seconds here just to remind me that 5 seconds has gone by. And then 5 seconds later I'm at 10. And then 5 seconds later I am at 15. So I've changed directions now. And then I'll be at 20 and then 25. And now when I'm putting my arrows in, I want my arrow to go halfway to the next dot, halfway to the next dot. Now at 10 meters, that's the spot here. At 10 meters is when I actually change directions. So instead of drawing my dot here and have my arrow going back, I think what I'm going to do is drop down first. So I'll put this dot at my lower level here. It's a little bit arbitrary when you do it, but I kind of like to drop this down as you change directions. So now I'm going back this way and I'm going back this way. And then this is my end position right over here. So I'll put end over here. Okay. Now if I compare this to when I did my finding the slope here, so if I look at this, this is the previous one, I found that in that first segment I was going at -2 meters per second, and in the second segment I'm going at 1 meters per second, so I could actually use that. So when I've got my motion map, I could actually label this here and I'll say, okay, over here I'm going, the velocity is equal to -2 meters per second, and over here the velocity is equal to 1 meters per second. I'm going to also label on this graph here that this slope here, the velocity for this segment here was -2 meters per second, and the velocity over here in part B was +1 meter per second. Now, and I know I'm still haven't gotten around to figuring out average velocity. Some people might say, hey, if I'm doing the average velocity, shouldn't I just average together these two velocities? Like, how do you average two things together? I guess you'd add them together, and you divide by 2. So if I did this, I would get negative 2 plus 1 is negative 1 over 2. I would get negative a half, or another way of thinking of it is negative 0.5 meters per second. I wonder if that's the right way, and I'm going to caution you. I'm feeling a little bit like I shouldn't show you this method because it's the wrong method. I'm going to show you that this is not the right answer, and we'll get to why it's not right in just a second. So in this white space here, I'm going to kind of remind you guys about some discussions we've had in the past about distance and displacement. So if I write distance here, I think I'll do distance in green, and I'll do displacement in blue. So distance is kind of like the odometer reading. Oh, I got to go back to green. It's kind of like the odometer reading in your car. It tells you how far you've gone. We also call this the path length. So in this question, how far has the object gone? Well, if we look at the graph, it started at 30 and then it went to 10, so that's a length of 20. And then from 10 to 25, it went 15 more. So this would be a distance of 20, and then this would be a distance of 15. So it would have been, the distance would be 20 meters plus 15 meters. So it would have been equal to 35 meters. I think I'm going to use the letter D for distance. And I just want to remind you that there's no direction here when we're talking about distance. Just like your odometer doesn't record what direction your car has been traveling, because it's been changing direction the whole time. And the official term for this is a scalar. A scalar doesn't have direction. So the next thing that would be the scalar that goes with distance is speed. So now I'm going to say speed is equal to distance over time. So if I want to say, in this case, my distance was 35 meters divided by, well, how many seconds went by? It was 25 seconds. So 35 meters divided by 25 seconds. If I reduce this, I can say that's 7 over 5. So I think that's 1 2/5. So it'd be 1.4 meters per second. So that would be the average speed. And for each of these things, for distance and for time, if we're doing the average speed, we want that total distance. So we added together the 20 and the 15. So that's how you do distance. By the way, this is also a scalar. There's no direction when we're talking about average speed. So if a person was running around in a circle, we could talk about their average speed, and we don't worry about the fact that they were changing direction. Okay, so now displacement's a little bit different. And while distance we use the letter D, for displacement we're going to talk about, well, first of all, I'm going to put an X here for position, because that's what we've been doing in this class for horizontal position. We've been using the letter X. So displacement is specifically the change in position, where position is that letter X. Oh, is the letter X. So change in is the triangle symbol, delta X. So I'm going to put beside here delta X for displacement. And when we do the change in position, in this case, well, we started at 30 and we ended at 25. So like this would be our change in position. So that would be, well, it went down 5, so it would be minus 5. Change in position in this case is going to be equal to minus 5 meters. So in distance we had 35. Displacement we had minus 5, and the minus part is actually the direction, isn't it? Okay, so some people just think, oh, the only difference between the two is that distance doesn't have direction and displacement doesn't, but you'll see 35 is also different than 5 because the way you do your calculations are different. Okay, so now here's the big thing that you're looking forward to, is how do you figure out now average velocity? So we'll say average velocity It's not the two velocities add together. Well, just how we did average speed was the total distance divided by time. This is going to be equal to my total displacement divided by the total time. So what was my total displacement? Well, we just figured that out. It was minus 5 meters. How much time went by? 25 seconds. So minus 5 divided by 25, I can reduce that. That becomes negative 1/5 meters per second, or I can write that as negative 0.2 meters per second. So you'll notice that in the beginning we thought, oh, maybe if we just average the numbers I get negative 0.5, but in fact we get negative 0.2 meters per second. I can give you some insight about why that is that it was going at minus 2 meters per second for 10 seconds, which seems like a long time, but it was going at plus 1 for 15 seconds. So this plus 1 should kind of have more weight to it, should be more important in my final answer than the minus 2. And so you'll notice that this number is actually to the right, is larger, closer to 0 than that negative 0.5. So for example, if you were going in your car 0 kilometers per hour for an hour, and then for 10 minutes you went 100 kilometers per hour, you wouldn't say that your average was 50, because you'd have to say, well, how far did I go altogether divided by how much time did it take? All right, so I hope that made sense for you, and I will see you in class.